Hi, everybody. In this video, I'm going to go through our final example for lesson on experimenting with dilations. So plot the image of PQRS after a dilation by a factor of 1/3. And one side note has been done for us. So this is not necessarily like our coordinate quadrant plane that we are used to. This is just a grid, but I still can count one dot to another as a unit. So P to Q, whatever that length was, that has been multiplied by a factor of 1/3. So 1/3 of whatever the distance PQ was, that became this P prime Q prime. So let's do the other side. So I'm going to now find the length of SP. So this length is 1, 2, 3 units. So SP is 3, which means then if I want to find S prime P prime, I'm going to take 1/3 of whatever SP is. So 1/3 of this length 3 is 1. So S prime P prime is going to be 1 unit, and it would be up from whatever P prime is. So I'm going to go from P prime up 1 unit, and this will be our new S prime. So now I can graph or plot this 1 unit tall S prime P prime. Now, this is where that process can't necessarily be duplicated in the exact same way. If I want to plot our final point, right, I really just need to plot this point R. These are diagonal distances now. So what I'm going to do here is I'm going to find the distance kind of from S to R. So I'm really looking at SR here. And I notice to get from S to R, I would have to go up 1, 2, 3 units. So SR, you go up 3, and then I would have to go to the right or over 1, 2, 3. So to get from S to R, one path I could take is I could go up 3, right 3. So I can cut these distances by our scale factor. I can multiply 1/3 to the going up 3. So I hope we note that 3 times 1/3 is just 1 because the 3's really just cancel each other out. So instead of going up 3, right 3 to find this S prime R prime, I'm going to go up 1, right 1. So to get from S to wherever R prime is, I'm going to go from S up 1 unit, and then I will go right 1 unit. And this would be our new R prime. No, I don't need these. So I can draw that length SR, which you could measure the diagonals, right? I could measure that this goes across 1, 2, 3 diagonals. So I would cut that into thirds, and 1/3 of that would be just one diagonal. That works for this one. It doesn't always work though. RQ is a little bit different. So there you might want to measure that to get from R to Q, you would go down 1, 2, 3, 4, 5, 6. And then you would have to go over 1, 2, 3. So in my mini diagram, I'm going to go, instead of going down 6, I'm going to go down 1/3 of that. So down 2 and then over 1. So it's almost like taking that scale factor and applying it to the slope in a way, but we're not really using the slope for its slope. I hope that you ask if you have any questions, and practice, practice, practice this because it makes perfect. And I look forward to seeing you in class.